The book gives us a list of, they call it a summary of modulus discoveries. Okay, so as you work through the problems in the book, you're supposed to discover these different things. I wanted to take a moment. We've in my previous video. Oh, excuse me. In the previous video, we talked about this one, how the modulus of the conjugate is the same as the modulus of the original complex number. And we talked a little bit about this. Well, we talked about this part right here. And then, but what I want to talk about right now is I want to look at this particular scenario. So I'm going to prove that to you. Okay, so what they're saying here is that the modulus of the complex number squared is equal to the complex number times its conjugate. Okay, so let's say that z is equal to a plus bi, and therefore z star must be a minus bi. And so when we multiply those together, a plus bi times a minus bi. What happens here is, we've been doing this for years and years, what we see is that we lose our middle term, and then we have a squared minus b squared I squared. Well, I squared is -1. A -1 times, a -1 here times a negative here makes this equal to a squared plus b squared. And so that becomes the value that you get when you multiply a number by its conjugate, a squared plus b squared. And so then if you think of this, this would be equal to the square of the square root and this underneath here, I've run out of space, I'm so sorry. This part underneath the radical is the modulus of vector z, because it just becomes this a squared plus b squared, take the square root of it. And so what we have shown here, the last step, I'm going to come over here, is that this is equal to the modulus of z squared. Oh, I guess I didn't show the very first step. The very first step would be what we have here, z times z star. So this becomes a pretty important, a pretty crucial property for us that we're going to see show up in future problems. So hang on to that idea. It will matter. Let's move into, we're going to do an example that works with this property. And here is our example. It's from the book, and here we go. So they are telling us to find the modulus of z, given that 5 times the modulus of z minus 1 is equal to the modulus of z minus 25, okay, where z is a complex number. So, oh my goodness, what is happening here? So as we get started on this, we've got this 5 is equal to the modulus of z minus 1. 5 times the modulus of z minus 1 is equal to the modulus of z minus 25. Now what I can do is I can square both sides. Okay, so if I square this side, I can square that side. And the reason that I introduced this idea of squaring is that then I can multiply by the conjugate, and it might clean up things a little bit. Or then I can use that property that we just discussed. So let's do that. So then I end up with 25 times the modulus of z minus 1 squared is equal to the modulus of z minus 25 squared. And so now with this, we just learned a second ago that this is equal to z minus 1 times the conjugate of that, okay, likewise, z minus 25 times the conjugate of that. And now we're going to pause for just a second and come back to this idea. I'll probably have to go to the next slide. But what I want to point out to you is if z is a plus bi, and I have minus 1, well, this minus 1 part right here is, this is real, this minus 1. So I could rewrite this as saying this is a plus, oh, I lied. Hang on. I didn't mean to lie, but I did. Okay, this is a minus 1 plus bi. Well, so once again, this is your real part. Here's your complex, or here's your imaginary part. So the conjugate of that, you keep the real part, and then just change the sign on. So you could use parentheses to kind of see a little bit better. But the conjugate of z minus 1 right here becomes, well, this is, excuse me, this, the conjugate there is a minus 1 minus b. This is the same thing as saying, well, a minus bi minus 1. Okay, so I could just rewrite this and say that this is, hang on, I didn't say this very well, but basically, if I have z minus 1 and I want to take its conjugate, what happens is it's the same thing as saying the conjugate of z minus 1. I can regroup things and kind of move things around. See how these two parts are the same but written in a different order. This is the conjugate of z minus, this first part here is the conjugate of z minus 1 because we changed the complex part. Okay, I'm sorry, that was a little confusing. Hopefully we made some sense of that. If I had more time and they paid me more, I would fix that part of the video, but too bad. Here we go. And now continuing from that last little bit, we were able to move the conjugate instead of being outside up here, we were able to move that and put it here. And we kind of explained that badly, but we explained that a second ago. So now I'm going to kind of FOIL everything out and distribute and all that great stuff. So this becomes 25z times z star, and then minus 25z minus 25z star. It's plus 1 times 25, so plus 25. And that is equal to, now here comes the other side, z times z star. Sorry that I didn't have more room. Minus 25z minus 25z star. Oh, I'm so sorry. Plus 625. Okay, and now when I look at both sides here, I notice that on one side of the equal sign I have a negative 25z and a negative 25z on that side. So if I added it over there, they'd cancel each other out. A negative 25z star and a negative 25z star. So at this point, I now have this 25z star plus 25 on one side of the equation, and then a z star plus 625 on the other side of the equation. Okay, if I clean this up, I can say this is 24z star is equal to 600. Okay, and now when I divide by 24, I get that z times z star is equal to 25. Check my math. And if you remember, we said that the magnitude of the modulus, the modulus of z squared is equal to z times z star, which is what I have right here. So this z times z star equals 25, oh, so sorry, is the same thing as the modulus of z squared equals 25, so therefore the modulus of z would have to equal 5. And they, technically we do our cheers, square root, plus minus, but our modulus is going to be positive. It's a certain length away from the origin, so that's a positive length. Hopefully that was helpful.